Let's see if we can find the limit as h approaches 0 of 5 log of 2 plus h minus 5 log of 2, all of that over h. And I'll give you a little bit of a hint because I know you're about to pause the video and try to work through it. Think of your derivative properties, especially the derivative of logarithmic functions, especially logarithmic functions, in this case, with base 10. If someone just writes log without the base, you can just assume that that is a 10 right over there. So pause the video and see if you can work through it. All right, so the key here is to remember that if I have f of x, let me do it over here. I'll do it over here. F of x, and I want to find f prime of, let's say, f prime of some number, let's say a. This is going to be equal to the limit as as h approaches 0 is one way of thinking about it. As h approaches 0 of f of a plus h minus f of a, all of that over h. So this looks pretty close to that limit definition, except we have these 5s here. But lucky for us, we can factor out those 5s, and we could factor them out. We could factor them out front here. But if you just have a scalar times the expression, we know from our limit properties we can actually take those out of the limit themselves. So let's do that. Let's take both of these 5s and factor them out. And so this whole thing is going to simplify to 5 times the limit as h approaches 0 of log of 2 plus h minus log of 2, all of that over h. Now, you might recognize what we have in yellow here. Let's think about it. What this is, if we had f of x is equal to log of x, and we wanted to know what f prime of, well, actually, let's say f prime of 2 is, well, this would be the limit as h approaches 0 of log of 2 plus h minus log of 2 minus log of 2, all of that over h. So this is really just what we see here. This, by definition, this right over here is f prime of 2. If f of x is log of x, this is f prime of 2. F prime of 2. So can we figure that out? If f of x is log of x, what is f prime of x? F prime of x, we don't need to use the limit definition. In fact, the limit definition is quite hard to evaluate this limit, but we know how to take the derivative of logarithmic functions. So f prime of x is going to be equal to 1 over the natural log of our base. Our base here, we already talked about that. That is 10. So 1 over natural log of 10 times x. If this was a natural log, well, then this would be 1 over natural log of e times x. Natural log of e is just 1, so that's where you get the 1 over x. But if you have any other base, you put the natural log of that base right over here in the denominator. So what is f prime of 2? F prime of 2 is 1 over the natural log of 10 times 2. So this whole thing has simplified. This whole thing is equal to 5 times this business. So I could actually just write it as it's equal to 5 over the natural log of 10 times 2. Or I could have written it as 2 natural log of 10s. The key here for this type of exercise, you might immediately, well, let me see if I can evaluate this limit. But you're like, well, this looks a lot like the derivative of a logarithmic function, especially the derivative when x is equal to 2, if we could just factor these 5s out. So you factor out the 5, you say, hey, this is the derivative of log of x when x is equal to 2. And so we know how to take the derivative of log of x. If you don't know, we have videos where we prove this, where you take the derivatives of logarithms with bases other than e, and you just use that to actually, and you find the derivative, then you evaluate it at 2, and then you're done.